Okay, moving on to question 2. The water in the swimming pool is heated by the sun, and then we need to state how energy is transferred. Right, now there's 3 types of mechanisms where you can have heat transfer. Okay, and that's what it's talking about. Like you can see, it's heated by the sun, so we're talking about heat transfer. So the 3 ways that that can happen is conduction, convection, and radiation. All right. Now, because the heat from the sun is coming through the vacuum of space, okay, because it's a vacuum, then there can't be any conduction because there's no particles to conduct in a vacuum. It can't be convection because, again, that needs particles, so it must be this one, it must be radiation. And if you're feeling particularly precise about this, then the part of the electromagnetic spectrum that is radiant heat is infrared radiation. So that would be the best answer there. Okay, state what happens to the average speed of the water molecules as the water is heated. Okay, this is just kinetic theory. Okay, if you heat up the water, then the average speed is going to increase. At night, the swimming pool cools down. Okay, and there's a couple of ideas that we could have to explain this. Okay, number 1, you're not getting any heating from the sun anymore. Okay, so the sun doesn't shine at night, so there's no heat being received. Okay, and then the other thing is that the ambient temperature at night is going to cool. So you've got your warm swimming pool and cool surroundings, okay, and that's the direction that heat flows in, from areas of hot or areas of warm to areas of cool. That's the direction of heat flow. So either of those kind of mechanisms could have explained that. Either there's a lack of heating because there's no sun, or there's increased cooling because the ambient temperature is decreased at night time. So now we've put a plastic cover over the top to reduce the cooling, and we need to explain how. Okay, and this is 2 marks, so we're looking to say 2 clear things here, right? So first of all, let's just try and get our heads around what's going on here, right? So we've got some water like this, and we're going to put a plastic cover over the top of it. Okay, here's my plastic cover over the top of it like this, right? Okay, and that's my plastic. So you can see between my plastic cover and my water, I've trapped a layer of air. All right, and that's one of the possible ways that you could explain what's going on here. Okay, because air, of course, is a good insulator. Okay, so if you talk about trapping a layer of air and then air being a good insulator or a poor conductor, okay, that's one way that you can access the marks here. Plastic itself is also a poor conductor or a good insulator. Okay, so either of these methods can reduce conduction, okay, because of the air or because of the plastic. Okay. The other thing that of course will happen is it's like putting a lid on top of it. It reduces convection currents, right? Because the area of hot air above the water, okay, rises up and then it hits the layer of plastic and it just recirculates like that. So because the convection currents can't carry heat away from the surface of the pool, okay, that's another way that we could explain what's going on there, that the fact that convection is reduced or stopped. And the final mechanism is that another way that you can lose heat is through evaporation. And if you put a plastic cover over the top, then we're going to reduce evaporation. Okay, so we've covered conduction, we've covered convection, okay, but we haven't talked about radiation yet. Okay, and why is that? Okay, radiation usually occurs where there's a significant temperature difference, okay, between 2 items, right? So for example, a hot light bulb, okay, will give out a lot of energy by radiant heat. Okay, the sun, temperature 7,000 Kelvin, okay, that'll give a lot of heat out by radiant heat. Okay, but you know, if your swimming pool's, let's say 25 degrees C, okay, and your surrounding surroundings are 20 degrees C, okay, that radiation isn't going to be a significant mechanism. All right. And then the other thing that you might notice about the cover is it's black, and black is very good at radiating heat. Okay, so that definitely wouldn't reduce the cooling. Okay, you've just made it black, so if anything, if you were going to get some significant amounts of radiation, it would increase the radiation more than anything, right? All right, time to move on to question 3.